So when we were convinced that opiates acted by opening potassium channels, we clearly wanted to move out of the enteric nervous system or even the locus coeruleus into parts of the brain where there was clear relevance to this. And the first place that we moved was into the spinal cord and the dorsal horn of the spinal cord, because these are the nerve cells that receive the incoming pain signals. So the afferent or sensory fibers that get activated when you have a painful stimulus, they terminate, the end, in the dorsal horn of the spinal cord. So we developed ways of taking the spinal cord, making a slice, and recording from it, and we found that the key neurons there were indeed hyperpolarized by opioids or by enkephalin. In fact, that's one of the Nature papers, I think, that was in 1982. And in fact, this was the first time that anyone had taken the spinal cord and kept it alive in slices. There's an interesting story around that, because I wrote to NIH for a grant to support this work, and the grant application was disapproved, not a low score, below the bottom of a low score. And the reason for that was because nobody believed that you could study the spinal cord in vitro. It had to be intact in the animal. So I then, we did the experiments. In terms of preliminary data, we had a paper in Nature that we'd submitted. We had a paper in the journal Physiology. We sent the grant back again, and this time it got a score of 3.4. It was just at the very, very bottom of the scoring range. Absolutely no hope of getting any money at all. So there was not a lot of belief around at that time that you could take pieces of the nervous system and keep them alive in vitro. Fortunately, we still had money coming from other sources, in fact, particularly from the National Institute on Drug Abuse, because it was the drug abuse connection that was really driving us forward. And it was absolutely fundamental to understand the actions of opiates on single nerve cells if we were to understand why people liked to take opiates. Yeah.